Hey everybody! Today we're going to be using angle rules to solve for an unknown variable between two parallel lines. So let's just go ahead and get ourselves a couple of parallel lines, and we know they're parallel because we put our cute little arrows on there. And we're going to start off with something fairly simple where we have an x and we have 140 degrees, and whether or not this is to scale, that really doesn't matter. My clever little cupcakes out there should realize that these are in fact alternate interior angles. Alternate interior angles. And I know that you know that the alternate interior angles of two parallel lines cut by a transversal are equal. Which means that this x has to equal 140 degrees. Alright, that wasn't so bad. But what happens if all of a sudden I go ahead and draw a couple of new parallel lines and a transversal, and we make them parallel, but this time I decide to go ahead and put 2x plus 40 degrees, and down here I put 3x minus 20 degrees, and oh, the horror! Why did he go and do that? But we can solve this. We can solve this because we can apply the rule that we just applied. If these are alternate interior angles, just like we knew that this x was equal to 140, we know that this 3x minus 20 must be equal to this 2x plus 40. So let's go ahead and write that out. If we end up with 3x minus 20 equals 2x plus 40, we can bring our x's over to one side, subtract 2x, 3x minus 2x is just an x, minus 20 equals 40. I want to get this x all by itself, so we're going to add 20, and we get a final answer of x equals 60 degrees. So even though it was an algebraic expression, we can apply the exact same rule and say that they're equal. That gives us an equation we can solve for x, which is our final answer. Let's go ahead and try this again with another situation. So this time, I'm going to give us a couple of parallel lines. And we'll give ourselves a transversal. Make sure that they're parallel by marking on them. And it's going to be 140 degrees and the x on the inside. Now, don't make the same mistake here of thinking that they are the same. What you don't want to do is say that this x equals 140, because it doesn't. My clever little cupcakes out there this time know that when you have two angles on the same side of a transversal between two parallel lines, that these angles are supplementary. And that means that they add to 180 degrees. So we can set this up to, instead of being equal, look like this. X plus 140 equals 180. We get our x all by itself by subtracting 140. Subtract 140, x equals 40 degrees. All right. But you know what's about to happen here? Oh, you know what I'm going to do. We're going to ramp up the difficulty. And you say, why? Why would you ramp up the difficulty? Do you not like us? And I say, I want to make you stronger and better and faster. And to do that, I'm going to make it 2x plus 20 degrees. And the other one on the inside, I'm going to make 3x plus 40 degrees. But we're going to solve it the exact same way. We realize that these supplementary angles, these two interior angles, must add to be 180. So we can still say exactly the same, that 3x plus 40, that's our first angle, just like this x, plus our second angle, 2x plus 20, must equal 180. Let's clean this up. We have a 3x and a 2x. That becomes a 5x, a 40 and a 20. That becomes 60, and it equals 180. We're going to get rid of the 60 by bringing it over. Subtract 60. Subtract 60. 5x equals 120. We're almost there. We want to get this x all by itself. So we divide by 5, and for our final answer, we get x equals 24 degrees. So even though it was an algebraic expression in between those two lines, we were able to solve it the exact same way using our angle rules. Hopefully that helped. Cheers!